Hey everybody, my name is Jen Shelton and I'm a fourth grade teacher. This last year was my district's first year with e-learning days, and throughout the process I found a lot of things that did not work well, but I also found some things that worked really well, and I'm excited to share those with you today. Please know before we get started that I am not a tech expert by any means. I had to learn these things as I went, and so you can absolutely do this too. My goal is really just to inspire you to get creative and think outside the box a little bit with your e-learning lessons. So let's jump in. My first thing to show you really is that my district created this template, and so we all had the same one across the board. It was super helpful for kids to be able to know we're all looking for the same thing. And I imagine it'll make it easier this year because they already have done the process. But let me go ahead to the next screen where you can see my instruction page for the kids, if it loads. And then here we are. So my first e-learning day, I really just did the list of instructions. And as you can see, it's a lot of text. My special ed teacher was awesome and actually voice recorded the instructions for her kiddos. But I still found that a lot of my kids didn't do it all or misread some of the instructions or things like that. And so I wanted to find a solution for that problem. So I ended up doing welcome videos to each one of my e-learning days. Didn't take very long to do that. I did all my assignments first and then I went back and did my welcome video. This was hugely successful. I got a lot of feedback from parents that just said, hey, my kid's excited to come to school because they know they're going to see your face telling them what to do. And so it helped keep kids a little bit more accountable. It also helped me to problem solve things before we got back on Friday and I had to, redo everything. So I'll let you jump in. This was during our cold week, so we had more than one day off. But
Day two, one more day. We've got 2.5 hours of work about to do today. Reading is going to be on Study Island and drop everything and read. Math is also on Study Island. Your writing is going to be a free write type situation. I did give you a topic to write about, and I want you to focus on some development instead of details. And then science, we've got an experiment to do. So you're going to need to kind of roam around your house and get some things out. A couple of things that I want you to note for today before you get started. The first one is my office hours are going to be a little different. Most of you needed help in the middle of the day yesterday if you needed it. So we're going to do 9:30 to 11:30 and then 1 to 3. So if you need things during those times, I'll be right there. The rest of the day I'll probably be pretty close to. The other thing is the survey. Most of you did this, or a lot of you did the survey after you did one of the assignments yesterday. The survey is for after you get done with all of the assignments. So it's okay if you did it wrong yesterday, no biggie. But today, go back and do the survey after you finish everything: reading, math, writing, science, and art. Today, you're going to do art today. Also, a couple of you did art yesterday. Make sure you go in and do gym and music today if that's the case. All right, have fun. I'll see you guys Friday.
So as you can see, that just helped me clear up a lot of things before we got back to school on Friday. Again, this was like a longer stretch. It was during our record cold week. And so I believe we did 2 e-learning days, but we were off for even more. And so that kind of allowed me to fix some things so we had fewer things to fix when we got back to school on Friday. The other thing you heard in that video is that we had to do 2.5 hours of work for our kiddos. And that's completely reasonable for a day of school. But I also, as an educator, didn't want to put my kids on the computer for 2.5 hours. So I kind of challenged myself to think outside a little bit and what can I have them do that's not on the computer. We were starting Force in Motion, or we were supposed to start Force in Motion the week that our record cold hit. And so we were kind of in the middle on science. We had finished the last unit, and so I was ready to move forward on the next one, but I wasn't totally sure how to do that. The day before this one, I did a mini lesson on Force in Motion where I just videoed myself kind of teaching that Force in Motion lesson. So then this day, I wasn't totally sure what to do. I ended up doing an experiment based on one that we normally do in the classroom. Normally, I give them the supplies and they work in groups to do it. But I got to thinking, hey, they can totally make this happen at home. So let me show you just a little glimpse of my science experiment that we had them do. So there are 3 videos that'll pop up here. There they are. 3 videos that just kind of explain the experiment, tell them what supplies to get, and then I kind of go through and model it. So we'll start with this one.
Hey, Sheltonians, welcome to Science. We are going to do an experiment today to figure out how different objects and different type of materials affect motion. So we get a couple of materials together. I picked things that should all be in your home, and if they are not, it is okay. You get a little choice. So the first thing that you need is two objects that you can drop down a ramp. The ramp won't be steep, but don't pick anything breakable. I picked my juggling ball from yesterday and then a Sharpie, things that won't hurt anything else and things that won't hurt themselves. So pick two small objects that can easily go down a ramp. The other object you're going to need is a ramp. And so obviously you don't have one of these in your home, but you can create one. So I made mine, let me turn this just a little bit, out of a stack of books with a cookie sheet on top to go down. If you don't have a cookie sheet or if you don't have a bunch of books, just look for anything to stack up and then something flat to go like this. That could be a board game, a notebook, like I said, a cookie sheet, anything that is just flat and straight. We need that ramp because we're testing variables today, and variables are the things that we change in an experiment. And when I test my two objects, my ball and my Sharpie, if I push them, I could push it really lightly, I could push it really heavily. That itself is a variable. We don't want to add that to our experiment because we want to test the variables that we want to test. So by dropping it on my cookie sheet, it's going to go with the same amount of force both times. So the one thing you need to make sure is that your ramp is consistent every time you do this. So don't add more books to make it taller or take away more books to make it shorter, because we want that inclined plane, that ramp, to be the same every time. So the other thing you are going to need is something to measure with. Now, ideally, if you have a ruler or a tape measure, that's what you should get, and you should measure in inches or centimeters. Just mark whichever one you do in the table. If you don't have a ruler at home, that's okay. I'm going to do it without a ruler today just to show you that it's okay to do it without a ruler. We're going to kind of create our own measuring instrument if you don't have a ruler. Again, if you have a ruler, use that. That's going to be more consistent. But I know you guys might not have one at home. So I'm going to use a pen, and I'm going to do the pen length as my measurement, and I'll show you how that works.
So then I jump in and I show them a little bit more about what it's going to look like to drop that ball, not to push it, but to just drop it slowly. I show them that looks a little angry there, but sometimes when you're concentrating, your face doesn't always look the best. Let's jump in right there.
Pieces of your
We're filling in all of our objects.
For our results, and so those we'll do as we go. All right, so I'm going to move this so that you can see my ramp for my first test. Did I go too far? Where's my ramp?
You can see,
okay,
like I said, not a tech expert.
So I'm going to take my ball. I'm going to hold it right at the very top. And I'm not going to push. I'm not going to shove it all. I'm just going to let it go. And you guys can see. Oh, good. It stopped before it hit something. That would have been bad data. But it went all the way down my counter. And so since I don't have a ruler or a measuring tape, but again, if I do, I'm going to use that. Since I don't have one, I'm going to use a pen to figure out how far it went. So I'm going to start it right at the bottom. I'm going to put my finger. That's one pen length.
So I go on and I continue to show them how to measure, and then I do the same with the Sharpie. So then my next task is to try it with on carpet instead of the countertop. So here's what that one was like.
All right, guys, so now we're going to try it on our second surface. So we were on a very smooth countertop last time. This time we're going to be on my more rough carpet. So I've got my ramp all set up. Let me get it so that you can see it. The ramp is set up the same way. I have the same books underneath it so that it'll be the same height. And I've put it in the same place on the book so that the ramp still will have the same angle. So that we're not changing those variables, we're just changing the surface to see how that affects the roll. So I'm going to start with the ball again, my object one. I'm going to start at the top, and remember, I'm not going to push it. I'm just going to let it go and see what happens. All right, you can see over there how far it made it.
So we go ahead and measure the ball, and then let me jump forward for the Sharpie.
So I'm going to start it at the top.
And I did go ahead and fill out that chart the whole way so that they knew how to do it.
And I'm going to drop it the same way I did last time. We're going to see what happens. Oh, that went one pen length, which is really about the same as last time because if you remember, it didn't go very far the last time. So there we go. Um, After you have conducted your experiment, your next step is to think about why those things happen. Why did the ball travel further than the pen? Why did the ball travel further on my smooth countertop than on my um, woolly carpet? So be thinking about those things, and there's going to be some questions underneath for you to answer too. We'll talk about it all. We'll get all of our data together and look at it as a class when we get back.
Okay, and then this third video was really just, I realized I had a lot of perfectionists and worriers in my class, and I didn't want them to be panicked because these weren't things that we had done at school yet. And so that third video is really just me reassuring them that even if they don't know the exact vocabulary to use, to just describe what happened. So then I'll jump down into the questions. I had a preview of what their chart could look like when they get done, especially, again, showing that they needed to show those labels like pen lengths if that's what they used. And then they had their own chart to fill in, and then some questions. Which object moved further? Why do you think that is? Which surface allowed the object to move further? Why do you think that is? What are two ways you could speed up your object? And what are two ways you could slow down your object? These led to some great discussion when we got back to class and we could all kind of compare what we did in our own homes and talk about why those things happened. The other neat thing about this is we all have kids who don't get their e-learning done on that day, but they have that whole window to complete it. When the kids came back and found out that it was an experiment that they missed, they were a lot more likely to jump back in and get those things done. They were excited to go do it. They were also all talking about, you get to see the inside of Miss Shelton's house, and they were shocked by this. So that was my science experiment. A few other things that I found to be really successful or exciting um, were I did a science question and answer. We all talk about how great it is to get experts into the classroom, and it is, but it's hard to do that. And so I used e-learning day one day to pull some of my engineering friends. They made YouTube videos of themselves answering some of the kids' questions, and then I popped that in there, and that was really beneficial. Um, I also really learned that, the first one I was reviewing a lot of things, and I was worried about going forward, like, are they really going to get it? But then on, I really figured out that just a quick mini lesson video is so powerful for your e-learning lessons. So don't be afraid to get in front of the camera and to videotape yourself. The other really good thing that my kids helped me come up with, they were struggling with knowing how to navigate things. And so I wanted to help with that. And so I used Screencast-O-Matic, which is what I'm using right now, free to use for the basic one. And I made a how-to section at the bottom of the page that just showed them how to get to my specials class, how to get to your reading, how to get to Study Island, and if you need help, message me. This was super helpful because it allowed kids to message me instead of parents, and so it gave them that much more of a sense of responsibility for their own work, which was cool. I got a lot more Canvas messages and fewer Dojo messages once I had that up. So friends, that is all I have to show you today. I hope that it inspires you a little bit to create, and I hope that you have fun doing your e-learning lessons. Thanks.